In software development, there is always a time when some functionalities need to be tested. You can choose between manual testing or automated tests. Today, I will explain why you should use automated testing in most cases, what it is, and the types of testing you can use. Most people are familiar with manual testing. If you want to check whether something works as expected, you can simply start the application and verify its behavior. Depending on what you are testing, the process may look different. Sometimes, it involves checking if the result matches your expectations, while in other cases, it may require sending requests directly to the API, bypassing the Graphical User Interface (GUI). However, no matter how you perform manual testing, it has one major disadvantage: it is time-consuming. This wouldn't be a problem if you only needed to check the correctness of the application once. However, even a small change in one part of the code can sometimes affect many other functionalities of the application. The conclusion is simple. Code needs to be tested multiple times, especially before deployment. This is where the biggest advantage of automated tests comes in. Although you need to invest time in writing tests once, they save you a significant amount of time in the long run. Automated tests can be run repeatedly without additional effort, ensuring the entire application functions correctly after every change. There are different types of tests. The first one is unit testing. The goal of this type of testing is to verify individual methods or functions in isolation. For example, if you have an application that performs various calculations, a unit test might check whether a specific function works correctly. Typically, you provide input and verify if the output matches your expectations, but the exact approach depends on the function's purpose. An important aspect of unit testing is that tests should be isolated. If your function relies on other parts of the application, such as calling another function during its calculations, you should simulate, or mock, the external dependency rather than executing it. This allows you to test all possible scenarios effectively. For instance, consider a function that first calculates a sum and then calls another function, whose Boolean result determines the next step. In this case, a unit test should cover both scenarios, one where the dependency returns true and another where it returns false. Unit tests should be fast and run without starting the entire application. They are generally less time-consuming, but this depends on how your application is structured. If your code follows best practices, writing and maintaining unit tests is easier. However, if the application is poorly designed, creating proper unit tests can be challenging. The next type of test is the integration test, which focuses on verifying the interactions between different components. For example, you can test whether the application sends an email correctly and updates a row in the database as expected. This type of test is usually more time-consuming and slower than a unit test. The next type is end-to-end, E2E testing. The purpose of this test is to verify the entire workflow from the user interface, UI, to the backend. It is similar to manual testing, where you enter data into a form and check if everything works, but the process is automated. For instance, an E2E test could verify that after visiting a specific URL, certain text is displayed, or it could navigate to a specific section of the page, fill out a form, and submit it. This type of test is the most time-consuming of the three. These three types of tests, unit tests, integration tests, and end-to-end tests, are the most fundamental. However, there are other types of tests as well. Functional tests ensure that specific features work as intended. Performance tests simulate high-load scenarios to evaluate how the system performs under stress. Security tests identify vulnerabilities and potential threats. Acceptance tests verify that the system meets business requirements. If you have the necessary setup to write unit, integration, and end-to-end tests, you can usually create other types of tests using the same tools and frameworks. For example, in Laravel, when you run the command phpartisan make test, you create a feature test, but it can easily be adjusted to another type, such as a security test. Often, when discussing testing, the testing pyramid is shown. There are different versions of it, but it typically includes unit, integration, and end-to-end tests. In theory, the application should have the most unit tests, followed by a slightly smaller number of integration tests, and the fewest end-to-end tests due to their complexity and broad scope. In practice, however, This can vary. There are projects where this isn't the case, and it can be difficult to implement this structure in existing applications. Each type of test has its purpose, and by combining them into a well-balanced testing strategy, you can not only ensure that your application is functioning as expected, but also make future changes more easily, even when you may no longer remember how everything works.